Hello, y'all. Welcome to lesson 65 of my DP chemistry curriculum. We're starting on reactivity 1.1.1. Chemical reactions involve a transfer of energy between the system and the surroundings, while total energy is conserved. By the end of this, we'll understand the difference between heat and temperature, as well as talk about quite a few other things in terms of chemical reactions and energy change. So, the first thing we have to do is, well, we've talked about energy, but what is it? Well, in the few cases we've talked about it, energy is often associated with energy levels. These are regions where electrons occupy different spacings away from the nucleus and they change in energy further or closer away. We've also talked about ionization energy. Now, ionization energy is a amount of energy we must put into an atom or a mole of atoms to remove 1 mole of electrons. We can have first ionization energy or successive ionization energies. However, energy itself is pretty much defined as the ability to do work. In addition to doing work, we could also say the ability to cause change. So either of these and both. Furthermore, it is always measured in joules. That is our unit, joules, or capital J is the unit that we use. Now, in your daily life, you're pretty familiar with energy. Furthermore, you're familiar with energy transfer. You may just not have direct names. So for transfer, we have a few methods. We have three that we classify. We have conduction, and that is the direct transfer of energy, usually through direct contact. We also have convection. Convection is not necessarily a direct contact, but it's transfer through movement of fluids. Now, in this case, we do consider gas as a fluid, as a follow fluid motion. So heat rising in a large house or just hot air moving up, that counts as convection, like maybe in your oven. And then lastly, we have radiation. Radiation is a transfer of energy through electromagnetic waves. Transfer through electromagnetic waves. So, for example, the sun heating us, bringing light into the earth and warming it in the form of visible, infrared, X-ray, UV rays, whatever. Well, not X-rays, but through UV, infrared, and visible, we are heating the earth, and that is radiation. Generally, a great way to think about it is if you've ever seen a pot on a stove, and we'll witness my terrible artistry right here. You have a little fire underneath it. Trust me, that is fire. And we're boiling some liquid in it, probably water. And so this fire is radiating light. So this is radiation. Inside, the hot water is rising. That is convection. And oh no, the pot is hot. So if you touch it with your hand, so now let's see if I can draw a hand. And you touch this hot pot, touching that would be conduction. We also, of course, have conduction here between the pot and the hot water. That's also conduction. So that direct contact with a solid, that'll be conduction. The movement of fluids, that'll be convection, and radiation is that light radiating out, in addition to things like infrared waves, which hit the bottom of the pot here. We also have convection. This hot gas in the fire rises and then conducts to the pot, making it hot as well. So these happen a lot in concert with one another. So you have to start thinking about how they all come together. Now, the big thing about energy is energy cannot be created or destroyed, just like matter. So this is our law of conservation of energy. Really, the only thing that can happen is that energy can change forms or be transferred. So energy can change forms or be transferred. So changing forms happens quite often. So maybe when you burn something, you're taking chemical energy, turning it into thermal and light. And transferring is like the heat radiating through from the fire to the pot, conducting, then convecting, and then conducting further or convecting further. So we have that happen a lot. So let's go through a couple changes that can happen. If we look at physical changes, we have to have things like melting or freezing. Melting happens through a gain of energy, while freezing happens through a loss of energy. If you have an ice cube in the palm of your hand, it starts to melt and your hand starts getting cold. Your hand starts getting all frigid. Now, the reason that happens is the ice cube is stealing your energy and therefore it is melting. So we often have a lot of physical changes that are associated with the gain or loss of energy. But this gets really interesting when we start looking at chemical reactions. And that's what this unit's going to be about. So with chemical reactions, the thing is, all reactions involve loss or gain of energy. Every single one. So we're going to have this energy change and energy transfer. Now, what is that chemical reaction? We kind of already know chemical reactions are when we uh, change slash rearrange atoms to form new substances. And as we do that, that takes energy. So it takes that loss or gain of energy. Now, when we lose or gain energy, this usually happens as a transfer of energy between what we refer to as the system and surroundings. So this is something that you will have to know the definition of. Our system is often defined by the reactants and products, pretty much everything in the reaction, while the surroundings is just going to be everything external, so everything outside the system. So when we start looking at these energy transfers and any changes, it's always best to look at an example. We'll talk about the example I mentioned just a little bit earlier. We'll do combustion of methane. This is a quite common reaction. CH4 gas plus oxygen gas will react, and every combustion with the hydrocarbon, something made of carbons and hydrogens, produces water, usually liquid or gas form, and carbon dioxide. This will usually be in gaseous form. So with this reaction, what's going to happen is the energy in the bonds here, in bonds, will convert into energy in bonds of products. But the only difference is we also get an excess of light and heat, often thought of as fire. So this is what most combustion reactions are, converting energy from the chemical bonds in our reactants to the chemical bonds of products. Now, while combustion reactions pretty much always produce heat and light, we do get energy in other ways, so we can often create electrical energy, but that's usually through oxidation reactions, and we find those in batteries. So there's a lot of other reactions we can do, but generally we have combustion for our heat and light, and oxidation for our batteries, which produce electrical energy that we use every day. The last part of this lesson is kind of the key point, which is what's the difference between heat and temperature, and how does this come into play? Well, the problem is that how do we measure energy? We've discussed before that energy within something is hard to quantify. We usually measure change in energy. Measure change in energy. And even so, that's a little hard to quantify as well. So what we do is that we use temperature change, temp changes, as an indicator of heat transfer. So then what is that actual difference? Well, heat on one hand is going to be the energy transferred from a system, or specifically from high temperature regions to low temp regions, while as temperature is just our quantitative measurement of heat. Quantitative measure of heat. So what I mean to say is if we have our pot of water that we looked at so long ago, and we have an initial temperature of maybe 25 degrees Celsius, and then we start boiling it because we put some fire under it, we can find a final temperature of 100 degrees Celsius, and we can use the change in temperature to quantify a change in energy. So it's going to be proportional. It won't be the same amount. So we're going to discuss this further on as we continue the unit, but hopefully this gives you a little introduction to temperature and heat and energy and chemical reactions, and have a great day.